Before we get to the show, I just want to call out the limited series we're releasing this week called The Normals. You might have actually seen the episode of The Normals drop into your feed on Tuesday. This was something that our team here at Science worked on. There are two more episodes to come. I hope you'll give it a listen. It was an amazing series to get to work on, and it's a fascinating dive into the history of normal human subjects in research. Okay, on with the show. This is the Science Podcast for April 9th, 2026. I'm Sarah Crespi. First up, freelance science journalist Hannah Richter is here to discuss NASA's plans to send a nuclear-powered spacecraft to Mars in under 3 years. Not having launched a fission reactor to space in over 60 years, NASA faces many technical and bureaucratic hurdles to make the deadline. Next on the show, researcher Erin Sandell discusses what looks like a chimpanzee civil war. The unprecedented violent split occurred in a large chimp colony that has been tracked by researchers for decades. Now they're asking, what can the lethal division of a chimp community teach us about human conflict? We're recording this interview as the Artemis 2 mission is doing its historic lunar flyby. Like right now, it's out there by the moon, about to curve around it, taking its crew the furthest ever from Earth. There's no landing on the moon this time. This mission, though, has been pitched as a prep for sending people back to the moon and even out to Mars. This week in science, freelance science journalist Hannah Richter wrote about NASA's recently announced plans for a nuclear fission-powered Mars mission that's expected to launch in 2028. Hi, Hannah. Welcome back to the Science Podcast.
Hi there. Thanks for having me again.
I think your story is very appropriately titled History and Mystery Surround NASA's 2028 Nuclear Mars Mission. So let's get away what we do know. Can you outline what the overarching plan is here?
Essentially, NASA surprised everyone when they announced a mission to Mars in 2028, which is the next possible launch date.
That's the next window that you can leave the planet and get to Mars in a reasonable amount of time.
Yes, and it is super close. On Monday, they told the community, hey, we're going to make an important announcement tomorrow. On Tuesday, they made this announcement that no one saw coming. And essentially, nuclear fission can power a spacecraft. It's called nuclear electric propulsion. That's what they'll try to use. It's an idea that people have had for over 60 years, but never actually made successful. There's a lot of reasons why that I'm sure we'll get into, but it's essentially a 60-year dream that, if this mission goes as planned, can come to fruition in only 2 years.
So they would put a fission reactor on a spacecraft, launch it into space, go to Mars. What are they going to do at Mars? What happens then?
At Mars, they're going to drop 3 payloads. These are all going to look a little bit like helicopters that modeled the Ingenuity copter that was really successful at Mars. And these 3 helicopters called Skyfall are going to use cameras and ground-penetrating radar to look for subsurface ice and maybe a spot that humans could land on a future crewed mission.
So the idea here is, again, it's not a sample return or anything like that. It's go look at Mars in a new way, also test out this idea that nuclear power could get us there. Why are people interested in this as a fuel source? We have been able to get things to Mars. What does going nuclear get us?
With this mission, going nuclear won't really get us much. It's mostly a technology demonstration. But the reason nuclear matters is because while Mars is close, a lot of the places we want to study in the solar system are not. And to get anywhere with our usual chemical propulsion rockets, you need a lot of fuel on board. Super heavy, super cumbersome. It also takes a really long time to burn all that fuel and get far out in the solar system. So if you switch to nuclear fission, you can bring a lot less fuel on board, and you can also get a lot further in less time. So Mars is really just a tech demo for that.
What would the timeline be for getting to Mars with this type of propulsion?
With this particular mission, which is called SR-1 Freedom, Space Reactor 1 Freedom, it's still going to take about 6 to 9 months, which is standard. But the goal is that in future, nuclear fission kind of builds up speed slowly and over time. The longer you're traveling, the faster you'll end up going. Mars could take 2 to 3 months, and somewhere in the outer solar system could take 2 to 3 years, whereas right now it could take a whole decade to get somewhere far.
And when you get there, you'll have a nuclear power plant, which would be very convenient.
Yes, you probably wouldn't take it off the spacecraft and start using it on the surface, but it is definitely the next step. Fission in space is still one step further than what we've got now. And it's going to be essential if we're going to stay on any, moon or Mars surfaces for a long time. You just need that kind of power.
And I think we should clarify that the nuclear reactions won't start until the spacecraft is in space. So it's not part of the launch.
Yeah, totally. So these reactors are launched cold, they call them, and they won't actually start being radioactive until they're far off of Earth. So you don't have to worry about, God forbid, a launch failure. You're not going to be raining particles that are radioactive down.
This is a fast timeline, as we kind of repeatedly pointed out. What pieces of this technology that have kind of been thought of and considered as a good idea for outer space? Like which parts of them are operable, available, can be put into a spacecraft at this point?
This is kind of a Frankensteinian mission in that you've got a lot of different parts from different places to make it work in the 2-year timeline. The fuel will probably be managed by the Department of Energy because they can work with, nuclear and radioactive material. The thrusters are going to be taken off of a project that was called Gateway, that was going to be this kind of moon space station. So we'll take the thrusters from that program because in the same meeting where they announced the Mars mission, they've decided to cancel this moon one. And then the fission reactor, the administrator of NASA said was mostly built. People aren't really sure where. Something that I was poking around into seems that it might be built at the Idaho National Laboratory, which already produces these small fission reactors with the right amount of power as the one they want to use on SR-1 Freedom.
So there are pieces out there that exist, but when you say Frankenstein, they have to be able to get them onto a ship and then get them to work together.
Right. And no one's ever really tried that. NASA's only launched one fission propulsion powered spacecraft. It didn't go so well, but not because of the nuclear reason. And that was in 1965.
65. Yeah.
1965. So 2028 is really fast to go from this many decades long quiescent period. The challenge is not necessarily like, can the reactor work and the thrusters work, but what happens when you put them together? Can they work together?
Can you walk us through how this actually creates propulsion?
Yeah. So in a typical rocket, you've got the chemical fuel that gets heated up and burned and shot out the back, essentially, in a very simplified way.
It's a nice explosion, controlled explosions.
Boom. These nuclear missions, you'll have fission that creates heat. That heat will get turned into electricity via a gas turbine. And that electricity will ionize a gas propellant and shoot it out the back as plasma. So you're still shooting stuff out the back, but rather than burning fuel, you are using nuclear fission. You're splitting the atom.
With the rush here, are there safety concerns, technological concerns? What are people pointing to and saying this could be a big blocker for launching something by 2028?
The big blocker that everyone I was speaking to really said was the boring stuff. It's the paperwork and the red tape. Maybe we can have all the technology together. It's safe. I mean, people think it is pretty safe, but getting radioactive fuel from place to place, there's a lot of permitting involved. And that alone takes normally longer than the amount of time the whole mission has. So they're going to kind of have to slash and burn their way to the launch pad.
Through the red tape.
Through the red tape.
Is that one of the main reasons that we haven't seen more nuclear powered spacecraft, because of all of this bureaucracy more than technology barriers?
Yeah, I mean, it's possible. One of the people I spoke with who's spent, their whole career studying this kind of stuff, he and his co-authors think it's something called mission pull. The technology might be feasible, but you need someone to say, let's launch a mission with it now. And nobody has actually done that up until this very ambitious Mars mission. There's something to be said for red tape. When you're using radioactive material, you want it to be as safe and as permanent as possible. It just means that this process is really slow and hasn't ever been fully successful, especially when we're not trying to get to the outer solar system. This might open up those opportunities.
Is it weird that this was a surprise? Don't they usually have a lot of warning and study and committees that discuss all these missions, prioritize them, and figure out who's going to get funded? And I feel like there's usually a lot of information released way before a 2-year timeline.
It is super weird. The fact that the community, including people within NASA, heard on a Monday that a big announcement was coming, and the next day the announcement came, that is super not typical. A lot of times with missions that overlap with planetary science, which this one is, I mean, they're going to Mars, you have the community say, hey, we want to do this. And sometimes that, hey, we want to do this can take a decade or more.
The decadals, right?
The decadal surveys.
Yeah.
This was not a mission anyone asked for. There's a little bit of where did this come from to the announcement. Industry players is probably one of the answers. There is a very ready and willing base of companies, not a huge one, but they're there, that want to be building these small fission reactors for reasons relating to science and definitely not relating to science. And the fact that this announcement was given without notice also means that there was not as much input as you would normally have with a mission.
From science teams, from engineering teams, that kind of thing.
Absolutely, yeah, from scientists and engineers. I was told by people that say they were familiar with the process that there were the people you would want involved, but those individuals, again, weren't scientists and engineers. They were decision makers. They were industry people. They weren't the people who will be doing science with whatever data comes back.
And is this part of a race to get nuclear fission into space?
Oh, absolutely. I mean, there's no hiding that being first in any regard in space seems to be a big priority right now. And this nuclear situation has been a dream for a really long time. To be first would definitely mean something. Russia and China are planning a moon base for 2030s that will have fission power. And this is kind of a way to sneak around the front and say, haha, we got there first in some regard.
Okay. And we have not talked about the cost of this yet. We have a lot of news on our site about the recently announced Trump budget. That's his recommendation to Congress for how science should be funded. Was this Mars mission in there, or do we know anything about how much it would cost?
This Mars mission was not in there, and we don't know how much it will cost. There are estimates that probably put it in the hundreds of millions. That's not atypical, but it's really curious that when you look at the NASA budget, the science is slashed by near 50% again, including the planetary science money. There's a case to be made that this is a planetary science mission, and if it's going to come from that budget, and we cut it in half, that leaves a lot less for everything else we want to do with all of the planets. But it's also a propulsion mission. It also paves the way to future human spaceflight missions. You know, it could really be funded in a lot of different categories at NASA, but it is not clear where yet.
Hannah, thanks so much for talking with me today.
Yeah, absolutely. Thanks for having me.
Hannah Richter is a freelance science journalist based in Washington, D.C. You can find a link to the story we discussed at science.org/podcast.
So good, so good, so good.
Everything you want for summer is at Nordstrom Rack stores now, and up to 60% off. Stock up and save on the brands you love like Vince, Sam Edelman, Frame, and Free People. Join the Nordy Club to unlock exclusive discounts, shop new arrivals first, and more. Plus, buy online and pick up at your favorite Rack store for free. Great brands, great prices. That's why you rack.
Ready to soundtrack your summer? With Red Bull Summer All Day Play, you choose a playlist that fits your summer vibe the best. Are you a festival fanatic, a deep end DJ, a road dog, or a trail mixer? Just add a song to your chosen playlist and put your summer on track. Red Bull Summer All Day Play. Red Bull gives you wings. Visit redbull.com/brightsummer ahead to learn more. See you this summer.
Also out on the site this week, in the news section, we have a feature story by contributing correspondent Mitch Leslie. He wrote about a new way of thinking about cancer metastasis. Up to 90% of cancer deaths result from tumor spin-offs, rather than from the damage caused by the original mass. Researchers used to think mainly about single cancerous cells moving to new parts of the body, but clumps of cancer cells are much more successful at surviving the transit. Looking at these cell clusters offers a new way of targeting cancer metastasis. Also, in Research and Science this week, mammals generally cannot regrow lost body parts, but the fingertip is a rare exception. In a paper this week, Byron Mui and colleagues ask, why do some injuries regenerate while others scar? It turns out the content of the extracellular matrix, this is a network of molecules outside of cells, is crucial to regeneration. If it's too stiff, it will form scar tissue, but keeping it softer with hyaluronic acid can push healing towards regeneration. Stay tuned for a close-up look at chimpanzee civil war. This week in science, Aaron Sandell and colleagues report on what looks like a chimpanzee civil war based on decades of observation of these wild primates in a national park. The question is, how do you get a civil war without civilization? I'm putting that in quotes. Aaron Sandell is here to tell us about this conflict and what it might actually say about how humans go to war. Hi, Aaron. Welcome to Science Podcast.
Thanks for having me.
I said decades of observation. How long have these chimps been under observation in the national park there? And this is the Ngorongoro National Park.
It's Kibale National Park in Uganda, and it's in the middle of this national park is this big population of chimpanzees, and these are the Ngorongoro chimpanzees. Scientists have been continuously studying these chimpanzees for the last 30 years, and there have been people in this forest studying monkeys and forest ecology for even longer.
So the basic outline here of this saga, this Game of Thrones type situation going on with these chimps, is there are about 200 in a really big group, and then they separated into two groups. They divided up territory and group members. Never the twain shall mix again. After the division, the smaller group then proceeded to raid and kill members of the larger group. This all happened over the course of 10 plus years, and it's a lot. So can we kind of start with what's unique about the situation? Do chimpanzees often break off into smaller groups, or, do other social animals like wolves do this?
Many animals that live in social groups, it's not unexpected for them to fission, to split into two smaller groups. And this usually happens if the group gets larger and there's not enough food available, there's increasing competition maybe within the group, and then the groups will split. And this is actually a way to reduce competition, reduce conflicts.
Yeah, you go over there, use that territory. We'll stay over here, use this territory. Everyone's happy, right?
Yeah, and it's still interesting. It's like then this group members who once knew each other now ignoring each other. It's different with chimpanzees because they rarely split. It's estimated to only occur once every 500 years based on genetic studies of chimpanzee populations. It's quite rare. And there's been only one other observed case of a chimpanzee group splitting, and that was Jane Goodall's chimpanzee she was studying in the 1970s. But at the time, it was the 1970s. People didn't really know as much about chimpanzees. They didn't know that they were territorial and that they would engage in lethal aggression. So it was sort of a shock when it all happened.
When it comes to observing primates that are in the wild, essentially, and that don't have anything to do with people, what does this process look like, the division of this group, through the lens of your method of collecting data?
It's this huge team of researchers and research staff that are going out in the forest. And we have somebody in the forest pretty much every day. And this has been the case for 30 years. And then we have Ugandan team members out there pretty much every day rotating, and students and everything. We go out in the forest and we know sort of where the territory is, and we know where the chimps might be based on what trees have fruit. One important thing about chimpanzees is they're never all in the same place at the same time. They're like humans in this way that they are constantly splitting up into temporary subgroups, like making decisions moment by moment. Who do I want to travel with and who do I want to eat with? This is called fission fusion. And you see it across a lot of different animals, but it makes finding chimpanzees harder. So in a given day, we have to find chimpanzees, and then we record who they're interacting with, who they're socializing with. And this is an area, it's around 40 square kilometers. So this is like walking from Central Park to Wall Street and trying to find 200 chimps across that area.
Hiding in that low density New York City. So what you're doing is kind of marking who is with who and what their activities are.
Finding some chimpanzees, recognizing who it is. We have to identify them all just by their face and their body. And we stay always around 30 feet away just to protect them from any human diseases and to give some nice distance so they just ignore us. But then also up in a tree, we have to be able to recognize them. And then we just record either pencil and paper or on a phone or a digital device, writing down the chimp. Who are they sitting next to? Who are they grooming with? Any other social interactions, aggression, friendly behaviors. And it's doing this switching among chimps all day. Well, eventually you can start to see who are they preferentially interacting with. And over the course of weeks and months, you can see, okay, this chimp likes to spend time with this one. And you can create these sort of social networks of who likes to hang out with which other chimp, and you identify sort of cliques and stuff like that.
So this is in no way automated. Not everyone's got a little RFID tag on them and you're just like mapping their affiliation and proximity like from space or something. This is eyes on.
If anyone could figure out how to do that in a completely non-invasive way with wild chimpanzees, I would love to hear. But right now it's the old-fashioned way. It's like, I am the apparatus, that's somehow measuring their behavior.
And you log all that data, who's with who, what they're doing, how often they're together, all that stuff. And when you kind of map those networks, what does this final split, this like decisive split look like in your data?
There was clearly one community for the first 20 years of research there. But even then, it was apparent that there was like substructure. There were clusters, which we see this happening with female chimpanzees across East Africa, Central Africa, or even West Africa to some extent, where females interact with a subset of their whole community and they spend most of their time in a certain part of their range. But at Ngogo, the males were also doing this. The males also had sort of clusters or cliques or neighborhoods that they spent more time in. But this was the case for 20 years. And sometimes people would say, oh, this is such a big community of chimpanzees. And they have this sort of neighborhood dynamic. They're going to split. But John Matani, David Watts, everyone who worked there knew that the forest was really lush. There was an abundant amount of food. It was sort of like, no, they can sustain 150, even 200 chimps. But that was sort of the wisdom of the first 2 decades of research. And then something changed in 2015.
What was this turning point, like where things started to look different?
It was a little hard to detect at first. This was when I was doing my PhD dissertation research. I was there for 15 months, and I'd been there a few summers before then, but I was still learning about chimpanzees. So I would see chimps from the 2 main neighborhoods, the Western neighborhood and the Central neighborhood, when they would meet each other, because remember, chimps are splitting apart and rejoining throughout the day. When they would meet each other, it seemed really intense. Sometimes there'd be screaming and chasing. This was sort of the natural way that chimpanzees interacted. There is sort of a risk to every reunion where they could be fighting and reestablishing their position in the dominance hierarchy. And I learned that, okay, chimpanzees are sort of melodramatic. They're screaming, they're chasing each other, but then they start grooming and they're sitting and they're cooperating together. But over the course of this year, from 2014 to 2015, the reunions became a little more tense, a little more aggressive. And the neighborhoods seemed to spend less time actually interacting. And there was this one turning point in June of 2015. I was with a bunch of chimps from the Western neighborhood. John Matani and Rechna Reddy were with a bunch of chimpanzees from the Central neighborhood. And I was following the Western chimpanzees. They're in the middle of their territory. And they heard chimpanzees nearby. They could hear them. And we were in the middle of the territory. This must be the chimps from the Central neighborhood. But the Western chimpanzees became quiet. Some of them started grimacing in this sort of fear or excitement. They started touching each other in acts of sort of reassurance. And it was as if they were hearing chimpanzees from the outsider group. And then when the chimps from the Central neighborhood came, rather than reuniting in this typical chimpanzee fashion, the Western chimpanzees ran and the Central chimpanzees chased them. And nothing like that had really been seen, where it looked like a inter-community, inter-group encounter rather than interactions within a community. And then they avoided each other for 6 weeks, and nothing like that had been observed before in all the 20 years of research on them. And this was the first time we as researchers were like, oh, something's changed. Are they going to split?
Was there any inciting incident? I mean, you kind of observed this, like, it sounds like an effect rather than, it sounds like a downstream effect of something that happened. Do we know what made them change their attitude towards each other, these 2 groups?
One interesting thing was that morning was the first time any researcher saw this one male rising in the hierarchy sort of establish himself as the alpha. The alpha male finally grunted in submission to this male who had been sort of challenging him and rising in the hierarchy. This was happening in the Central neighborhood. And then that evening, when I was with chimps from the Western neighborhood, that was when they got nervous and ran away. So to me, I mean, partly looking back on it, but even at the time, it made sense that, okay, there's a risk to every reunion where they're establishing where they fall relative to one another. It could have been hours or days or even weeks since some of these chimps had seen each other. But now if there's ambiguity in the dominance hierarchy, this poses an even greater risk. because now the former alpha who's been deposed might want to let off steam and he might be really aggressive to other chimps. This new alpha, this young adult male who's sort of establishing himself in the hierarchy, is going to probably want to make sure other chimps are grunting to him in submission. So it makes sense that the Western chimpanzees are like, we can't deal with it. We're going to just avoid it and run. But the problem is that sort of plants the seeds for polarization. So even though they reunited 6 weeks later and on the surface things seemed to return to normal, over the next 2 years, they became slowly more polarized, spending less and less time together, occupying different parts of the territory.
And this to me is even more mysterious. The separation kind of becomes complete. They don't see each other anymore. They don't reproduce across groups. But then you start to see these raids, like from the smaller group that broke off into the larger group where they're killing males and eventually infants. How do we make sense of that?
Well, one important thing to know about chimpanzees is that they are very territorial. They will have hostile interactions with chimpanzees from other groups, from other communities. Male chimpanzees stay in the group in which they're born. They grow up there. They spend their whole lives there. And they're the main participants in intergroup aggression. Females will also participate, but it's mostly males. And they do this somewhat distinct behavior among animals of going on these territorial patrols to the edge of their range and even into the territory of other chimpanzee communities. And it's a striking behavior where they often fall completely silent, often walking in single file line. And if they catch a lone adult or adolescent male from another group, they'll try to attack and kill him. And if they see a female from the other group with an infant, they'll attack her and take the infant, kill the infant. They don't usually kill the female, but they'll often kill that infant. We know that chimpanzees do this lethal aggression, especially with chimps from other groups, occasionally within communities, but we don't really know why that's happening. But the vast majority of lethal aggression occurs with chimpanzees from other groups. So the main idea is it's sort of like a fear of strangers. Adult male chimpanzees don't know any of the males from the other groups. They've never met them. And it's almost this xenophobia that is the basis for territoriality. They fear the males from other groups. They'll attack and kill them. And the lethal aggression seems to have certain benefits because if they're able to expand their territory where they've been making these lethal attacks, then they get more food, bigger space. This is a benefit to the females. They can maybe have more offspring, which is some research that our team has recently analyzed. So there seems to be benefits for expanding the territory. But when the groups split at Ngogo, when we now have in 2018, these are two separate groups. On the one hand, it makes sense. Okay, the Western chimpanzees, they're just now doing these territorial patrols and attacking the central chimpanzees. On the one hand, this makes sense because now they're separate groups. So
they have territory, they have borders.
Exactly. They have this new border has emerged. They're two groups, so they're doing lethal aggression, which we see in chimpanzees between groups. But what's really different here is these are not strangers. These are chimpanzees that they grew up with, they were cooperating with for years, they were grooming, they were participating in territorial behavior together, which is this really risky context where you could be killed. They were sharing food. These were chimps that would hold hands. Now they're trying to kill each other.
And the rate that they're killing former members of their group is a lot higher than typical territorial patrols, right?
It's hard to estimate, but this seems far above what is normal for chimpanzees and far above what is even normal in human warfare. I mean, at least in this non-industrial, non-nation state type warfare. Yeah, they're killing at least one adult or adolescent male every year. Starting in 2021, they started killing infant chimpanzees from the other group. Now the Western chimpanzees almost kill every infant that's born from the central female chimpanzees.
Wow. So this is still ongoing. Here we are in 2026.
Yeah, we saw the first lethal attack in 2018, and it's this ongoing conflict. Another just important thing to note is it is one-sided. At first, the central group and the Western group were both engaging the territorial patrols, but the central group never attacked and killed a chimp from the Western group, whereas the Western group has been quite effective at attacking and killing chimps from the central group. And it's partly, even though they were smaller, they were more cohesive. There were only 7 adult males when they first split. but they spent a lot of time together. They're always together, whereas the larger central group still had these two neighborhoods, the sort of eastern and central neighborhood. They were less cohesive. And that was really, I think, the disadvantage for them, is that they weren't as coordinated. They weren't as engaged in this collective behavior.
I saw in the paper that there was some important connectors, like chimps that had kind of traveled between the groups that died out.
That's something that we're definitely trying to analyze now, which is statistically difficult. But one of the big shifts in 2015, where the social group became really polarized and the neighborhoods that had long existed are now spending more time within neighborhoods, less interactions between neighborhoods. Part of this, as I mentioned, seems to relate to the change in the dominance hierarchy. But what happened a year earlier was that 5 adult male chimpanzees died somewhat abruptly over the course of a month or so. We're not sure how all of them died. Some of them showed signs of illness, so it could have been a small disease outbreak. These were older males. They were in their late 30s and early 40s. They were socially connected older males. And I think, on the one hand, 5 adult male chimpanzees dying is going to be a shock to the social network and to the community. But some of these individuals, I think, really were these bridges among the neighborhoods. And this emphasizes the point that neighborhoods and even cliques aren't a bad thing for cohesion and cooperation, as long as they interact somewhat with each other and you have multiple connections among those neighborhoods and among those cliques. And when those 5 chimpanzees died, it was in the subsequent months that we saw this increase in modularity, where the neighborhoods are now spending less time interacting. So you have a large community, 200 individuals almost at this point. In 2014, 5 adult male chimpanzees die. That's going to weaken ties among individuals. So you have a weakened social fabric, increased sort of tension with the rising male in the hierarchy who eventually becomes the alpha. And those were probably the biggest factors.
As someone who's been watching these animals for so long, has this been hard to watch? It sounds fascinating as a scientist, but maybe is it difficult to kind of observe all like this lethal aggression, this dissolution of a community?
Yeah, and it's difficult. The first lethal attack that I observed was the Western chimpanzees killing this 16-year-old male, Errol. We give them all names to keep track of them. They killed the chimpanzee that I had known for years. He was an adolescent that I focused on for my dissertation research. So I spent 15 months of my young adulthood watching him sort of mature and grow up as an adolescent. And then coming back a few years later, I continued to watch him. And I remember seeing him in January 2018, and he was this small 16-year-old male. But there was one day when he was charging around and puffed up and running at females and grooming with females. And I remember coming home that day and saying, wow, he's really become a real adult male chimpanzee. And it was sort of sweet to see. And then the next day, I found that he had been severely attacked. And then I watched the Western chimpanzees attack and kill him. And in that moment, it was intense. I felt like a war correspondent. I went into this sort of objective, okay, just document what's happening. Okay, they're attacking him. When they finished attacking him, I followed the Western chimpanzees and just documented this all. And then we inspected the body with a Ugandan vet and everything. That night, though, writing the email to my senior colleagues and mentors and writing that email, it was like, this is confirming that this chimp has been killed. But also to me, it was like confirmation to me that the split was permanent and that they were starting to shift and treat each other as outsiders. And that's when, I started to feel it. That's where the crying in the shower and the whiskey and stuff come in more.
Oh man, that's awful. I can't imagine.
It's sad to see these chimps killed and being there. It is sad. But for some reason, I don't know if this is partly my temperament or something as a scientist, or this sort of becoming almost like this war correspondent trying to document it. What I'm most interested in is, why is this happening? Because I think it not only gets at the heart of chimpanzee behavior, what holds a community together, when do they fall apart, but it does seem to give insight into some aspects of our own behavior. And this is not to say that, okay, chimpanzees being one of our closest living relatives, we might be able to reconstruct what the behavior of our last common ancestor was. It's not quite that. It's that we can see chimpanzees behaving as they are and try to understand that dynamic and then reflect upon what it means to be human and what similarities exist in chimpanzees and humans today. What similarities might there be in sort of the mechanisms and the causes of lethal conflict?
How long do you think that group has been together leading up to this?
This is where, from genetic evidence, there are ways to infer this, and it's hundreds of years.
Older than the US, right?
Yeah, it could be 250 years. Yeah.
So in the intro, I mentioned this is a civil war, and I'm putting quotes around it because, but the kind of the important takeaway here could be that there isn't any kind of cultural difference, which is often what humans will point to and say, oh, they have a different religion, they have different political beliefs. This is why what was once a single group or community has divided and started being violent with each other. We don't think that's what's happening here. So can we say this is some other form of civil war or some other reason that groups divide and fight?
I do want to say that we should be careful in what terms we use. It's not quite war in the way that maybe many anthropologists or sociologists would describe war in humans, which has a specific meaning, but it's very similar to some types of warfare we do see in humans. It is this distinct dynamic where it's one community and it's individuals that once knew each other that are now killing each other. And this is eerily familiar to what we see in civil wars, internal wars, and other conflicts. And when we see civil wars in humans, like you're saying, we often attribute it to these cultural markers of group identity. Chimpanzees don't have religion. They don't have anything like ethnicity the way we have it. So we can't attribute this to those common sort of cultural markers of group identity. So in a way, it must be these shifting relationships. On the one hand, these enduring social bonds and the cliques that form, but then combine that with the rivalries and even these sort of moments of tension and avoidance that then can escalate when you start following along with chimps in your clique. You may not have a problem with that chimp, but if your buddy does, you're going to also start avoiding it. So then you can have these inter-individual conflicts escalate into sort of a group level conflict.
If your friends have beef, then we have beef, right?
Right. We see this throughout human life. And those political scientists who actually study outbreaks of civil war and look at the local dynamics, they see something similar. They say, okay, yeah, there's this broad conflict that's happening in a region, maybe about ethnic divisions or religious differences. But when they actually see who's actually fighting and why, especially at the outset of those conflicts, it's usually not attributed to the ethnic or religious divide. It's about interpersonal dynamics, interpersonal rivalries.
Yeah, super interesting.
There's a possibility that even in humans, even we attribute these conflicts to cultural differences, but actually there's something going on more with the interpersonal. And if this is the case, this is where I have hope, and even we can learn something from this chimpanzee conflict, because if it's true that we can get these major conflicts, even this lethal violence just from relationships alone, that means that we have in our relationships alone the power to intervene and bring about peace potentially.
So you can't point to say this is 100 whatever year old conflict. We can't solve it because of its history and its like deep cultural meaning. You could say, but have you thought about being friends? No.
Yeah, no, that's part of it. I mean, it's like, maybe I sound naive saying
no,
this.
I love it. I'm into it. I think it's important because I do think that going back to the Game of Thrones, this is not about people's beliefs. This is about history, revenge, personal dynamics. It isn't about some broader meaning. And we want to say that that is because it sounds better, but maybe that's also makes it harder to solve.
Yeah, I think it does. It's such a rare event. It is like, if this only happens every 200 or maybe 2,000 years, it is a rare thing. And that's one thing to note in comparisons to humans. Chimps are similar to humans in that when the group's splitting, lethal violence ensues, unlike many other animals where when they split, it seems to reduce aggression. But in humans, this is more common. In chimps, it's rare. So another question is, why don't chimp groups split more often? And what are the ways that they are able to stay in community and to avoid this escalating conflict? And it points to the importance of social bonds and forms of reconciliation and reassurance that chimpanzees are probably doing constantly that we don't necessarily even notice. I mean, there's a lot of research on this topic, but like you only really can identify what holds a community together when you see that it's falling apart.
Aaron, thank you so much for talking with me. This has been just amazing to hear about.
Thanks so much. Thanks for having me.
Aaron Sandell is an associate professor in the Department of Anthropology at the University of Texas at Austin and co-director of the Ngogo Chimpanzee Project. You can find a link to the paper we discussed and a related commentary piece at science.org/podcast. That concludes this edition of the Science Podcast. If you have any comments or suggestions, write to us at sciencepodcast@aaas.org. To find us on podcast apps, search for Science Magazine or listen on our website, science.org/podcast. This show was edited by me, Sarah Crespi, and Kevin McLean. We had production help from Podigy. Our music is by Jeffrey Cook and Wen Koi Wen. On behalf of Science and its publisher, AAAS, thanks for joining us.